So now I would request our first presenter, Dr. Sarmad Hanif and Dr. Jane Alom from Pacific Northwest National Laboratory to talk about their topics. Thank you. I'll stop sharing my screen so that the speaker can share their screen. Thank you so much.
Hello. Hi, Vice. Can you hear me? This is
Yes, yes, we can hear you.
So what is the preference? Should I also put on my video or?
Yes, I think that's better.
Okay, so let me try that. So can you see my video?
Yes, I can see you.
Right, so let me share my screen. So can you see my screen now?
Not yet.
Yes, can you see it now?
Yes, we can see it.
All right, so let me put it in the. All right, so thank you, Vice, for the introduction of the panel and inviting us to talk about peer-to-peer energy.
Your slide is in the. You need to switch the display because we are not seeing the presentation mode.
Okay, so
at the top there's a display setting.
Okay, so how does this work? So if
So when you go to Zoom, when you share your screen, you now you selected the wrong screen. You have to select the other screen. That will be fine.
Okay, so you mean if I go to Zoom and I share screen. All right, so let me know if this works now. So does this work?
Still waiting for the screen. No, it's the same screen.
Yeah, at the top you see a display setting at the second button at the top.
In the Zoom?
In your current screen, you move your mouse. Oh no, you go to the presentation mode. You go to the presentation mode.
Oh, okay. So where is that?
Oh no, just like just now, you show the slideshow.
Yes.
Just like just now, you show the presentation from the beginning.
Click from
Okay.
beginning.
Okay.
Let's see what.
And do you see at the top there's a display setting? Yeah.
Yes. Yes.
Yes. You saw.
Okay.
Yes, correct.
Great. So this is better. Okay. Thank you. Thank you. Right. Okay. So thank you very much. Sorry for the delay. Thank you, Vice, for inviting us to speak on the on this nice panel session. This is Sarmad Hanif. As Vice already mentioned, I'm a power systems research engineer at Pacific Northwest National Lab. I'll be presenting a talk on consumer-oriented electricity market and transition challenges with my colleague, Jan Alam, whom you will hear from very soon. Okay, so I'll just dive right in. So before we talk about these new market mechanisms and these new types of uh, innovative sharing of energy schemes, maybe it's a good idea to just take a step back and let's just briefly explain how usually the wholesale electricity market, bulk power market is usually organized, and that really came after the work done on spot pricing of electricity by Schweppe and Karamanis. And what basically this started was that a lot of independent system operators started trading energy and different types of products in wholesale market. So the figure I'm showing on the slide basically shows a independent system operator having a pool where it trades a day ahead market, which it trades energy in day ahead market, in adjustment markets, or and also balancing markets. And what happens is that there are a lot of different actors which are interacting in these markets. For example, producers, they try to sell their energy, and consumers, they try to buy their energy. And consumers usually, if they are not a very big consumer, they are basically going through a retailer, which from their behalf sometimes purchase energy. So if you think about it, it's a very central type of energy trading mechanism. And there are, of course, many things which are not traded, which are very essential to the operation of power grids. For example, reactive power management usually is not traded competitively. Black start, which has become very popular due to resilience issues, they are not currently being traded competitively. And the main topic for our panel here is how you can have more decentralized, more consumer-oriented energy trading in the current system. So with that, if you see the current structure, there is really not much of consumer engagement, and we would somehow try to show what's usually happening on the consumer end. Consumer like you and me, small consumers and residential, and usually also big consumers, but what do they pay for their electricity is basically rate, dollars per kilowatt hour. So the energy they use, they pay for it, and how much they pay is usually a decision by a distribution company, which operates, or let's say design the rate such that it recovers the cost of supplying electricity to the consumer. There are different types of rates. For example, a flat rate, or a time of use rate, how you consumed energy during the time of the day, and based on the different time of use tariff, you pay for it. Sometimes there is a tariff which is usually a critical peak pricing type of tariff, where they try to push you to consume energy during the low load periods. So these tariffs usually, of course, they vary a lot, and this is a very simplistic view. But if we really see in the current paradigm, what we don't see is that there's really not much options to buy energy by consumers, unless, of course, if you're a very big consumer and you can directly have an impact and perform and participate in demand response programs. So there are some programs which allows you to do that, but usually if you're not one of those big consumers, there are not much options. And this has been, according to my understanding, the way things have been. But this definitely is now under a lot of threat, because now things are quite changing. I just picked up some quote from Duke Energy CEO. The quote is quite big, but what I understood from this is that the utilities have realized that since we are living in an era where consumers have so much choices about the service they use, the product they use, they trade, and the prices they could pick from depending upon different types of services. So this needs to be translated also into our power systems, especially when there is now a whole new level of technology innovations happening at the consumer end. The consumers are just not simple passive energy consuming components of the grid. They are also becoming prosumers, so they can also produce energy, generate energy, and inject into the grid. So since these technology innovations are coming up, what we could imagine in the near future is that there would be more platform, more mechanism, more types of services that will be offered to the consumers, residential consumers also. Um, so with this theme, there is certainly a lot of work which has been going on, and what this work is trying to look at is, given the current. So about the slide here, we have two pictures, one on the left and one on the right. So left is, as I mentioned earlier, this is a very conventional view of how markets are organized. And on the right, I have picked up a schematic from one of the papers where basically a peer-to-peer energy trading architecture may look like, where every prosumer in principle could, uh, in theory, purchase and sell energy to any other prosumer, given the connection, given the availability. So if you really think about it, this is a big change, um, considering how current markets are organized. So if you were to bring this change, this will be a big shock to the system. Definitely, if not from the power flow perspective in managing the security of the system, but in general from the utility operation point of view, regulation point of view too. Of course, this is not, we don't have to go between one extreme and the another extreme end. There is also some innovative things you could do. And now I compare here two pictures. One, of course, was an extreme view where every consumer could just purchase energy from any other consumer. And let's say there could be a more intelligent way to organize this. And an example given here is from a paper where the authors, they sort of geographically connected the active components of the grid, which can potentially trade energy. And what they could do is, in principle, they motivated a community manager for that geographically oriented areas, and those communities can be looked after by that community manager and help them trade energy more competitively. And of course, they also, in the example given here, they also encourage the coordination with the system operator, so that other consideration which may not be very vital to the individual community manager, they can also be taken into the consideration of the trading. So this is a very high level view of some of the things which we think can be adopted and can be modified from the conventional conventional operation of the market. And how PNNL, Pacific Northwest National Lab, have also somehow explored this area. I want to give an example of one of the projects that was done quite a while back. I think in 2007. At PNNL, there have been many demonstrations like this, and I just have picked one just to show that there has been considerable effort in understanding how such a local retail type of market, which is dynamic in nature, which can adjust prices based on the system condition, how it may affect. So what one of the projects which I'm showing on the slide, it was under a grid-wise testbed demonstration projects. This project was the slide I'm showing is specific for this Olympic Peninsula project, where the goal was to have an economically dispatched controllable asset system, which could change its conditions based on the economics and the control. So the goal was to have a control which was economically driven, and why we wanted to do this was to also basically understand if there is enough capability in the system in a local level to basically change the behavior of the system, and what would it really take for a utility operating a distribution grid to really incentivize the actions which we want to obtain from the consumers participating in energy trading. So the project itself, it was on an area where the feeder load was roughly 1.2 megawatts, so it could go up to 1.2 megawatt on a peak load time. So there were controllable assets, including 5 water pumps, roughly serving a load of 150 kilowatt, to diesel generators, local diesel generators for resilience purposes. If there was some small brownout or a blackout where they wanted to support the portion of the grids, and an innovative thing, there was also 112 homes were contracted with electric, water, and space heating, roughly averaging to 75 kilowatt. So these controllable assets were basically operated using two-sided real-time, so like a double auction real-time retail market clearing. So the picture I show here for the market clearing, you could see here we have 2 offers of generators and then responsive load, and they are stacked against the supply curve, which utility had estimated they incur from day to day, and on a day-to-day basis. So of course there were a lot of variables which were analyzed, and I wanted to capture some of the main findings from the work. So in conclusion, which was found was that useful market-based response was achieved. So what I mean by that was, for different types of objective, for example, resolving a congestion issue at a distribution grid feeder, or reducing a peak load during a hot summer day, we were able to show that through the operation of controllable assets, and this was also one more like one step deeper into a retail market, dynamic retail market, because what we were, from the double-sided auction, we were able to operate, so to say, a shadow market, which was really like a marginal price for the last megawatt cleared. And based on those marginal prices, we were able to somehow calculate the incentives and drive a system, and the consumers enrolled in the program, and calculate their incentives which they could in principle incur. And it was a very innovative type of incentive system that was put in place, where $150 was given to a controllable asset per house, and based on the load shifts that were asked from them, they were credited back the amount of the money they were owed to utility, or or if they would do more, they would, or if they would do less, they would have to return back some of it. So around roughly $150 per month usually was the incentive which on average a controllable household was able to achieve. And of course there were many factors based on, because it was done on an actual system, there were many factors which played into it. And sometimes of course you would have to compare it against different types of tariff, as I mentioned, time of use tariff, or or a flat tariff, and we did some calculation on the cost basically of the system, which gets also exposed to all these because of these extra control that you're doing. But we would still take it as $150 a month saving, which could incur based on a household which has a space heating and electric water heating. And of course, if you're interested, you could read more about the report, which is listed here. And with this, I sort of tried to gave you a little bit of background of where we think from the conventional system how we could link these new trading mechanism. And I would now like to invite Dr. Jan Alam, my colleague, to say a few words on the transition challenges that usually happens when you have new technology being vouched for in the utility business. So John, over to you.
Thank you, Sarmad. So Wise, I would like to request Sarmad to advance the slides for me, if that's okay.
Yeah, that's fine. That's fine. Yeah.
Okay, great. Thank you. Hi, everyone. My name is Jan Alam. I'm from Pacific Northwest National Laboratory. I've been here at the lab for about 4 years now. Before joining the lab here, I used to work at UQ. So really great to have some of my colleagues here at this panel, and Wise is obviously one of them, and there's also others, and looking forward to hear from them as well. So thank you for the opportunity. And so I forgot to switch on my camera. Let's just do this.